Good afternoon, geometry. Today we're going to go back to circles. We just did a whole chapter on circles. Today we're going to specifically talk about two things. We're going to talk about the area of a circle, and we're also going to talk about the area of a sector of a circle. So first let's just start with talking about finding area of a whole circle. We do have a formula, area equals pi r squared. So for example number 1, we're trying to find the area of circle P. So I have my formula, and according to the picture, we know what the radius is. The radius is 12. So if I were to square the 12, I would get 144. So I have 144, and then I also have pi. So for this answer, I can write 144 pi. I do need to include units. My units are inches, and because it's area, I have to square those, or here's where we could use a calculator. Now I'm not going to plug in 3.14 because that's rounded. So what I am going to do is use the pi button. So I'm going to do 144 times pi. Got my pi button there. Going to hit enter. Oh dear, I have it on math print. Let me put it on classic print. That should change this. So we're going to do 144, hit the pi button this time. What am I doing? What am I doing? I have no idea. Well, there we go. I'm not really sure why I wouldn't do that the first time, but anyways, and there's kind of a glare there. All right, so let's round it to, I don't know, what do I normally do? 2 digits or 1 digit? Let's do 2 digits after the decimal point. So we're gonna say that this is approximately 452.39. So let me write that down before I forget it. 452.39 inches squared. Okay. All right, so example 2 says find the diameter. So at the end of this problem, we want to know what D is, the diameter. So I'm going back to my formula here. Area equals pi r squared. Now this problem, the information that we're given is the area. So I'm going to replace the A with a 52. And my goal at the end of the problem is to solve for diameter, but in this equation, I need to solve for r, which is the radius. So first thing I'm going to do is divide both sides by pi. So right now I have 52 over pi equals r squared. And then I need to get r by itself. And the way to do that, we got to get rid of that squared. So we're going to square root. Now, anytime you square root both sides, we include plus or minus, but for this particular problem, we will not include plus or minus because you can't have a negative radius because that represents a length. So I'm going to use the approximate symbol because I already know this isn't going to come out to be a nice, pretty answer. All right, so I'm going to do the square root of 52 divided by pi. Again, use the pi button. Don't punch in 3.14 because the pi button is more exact. It has all of those digits there behind 3.14. So square root of 52 over pi. I'm going to hit enter, and I'm going to again round it to 2 digits after the decimal point. So the 8 is going to round the 6 up. So we're going to say that the radius is approximately 4.07. Now our math looks good, but this is not the final answer because the question wants us to find the diameter. So what do you guys remember from the last chapter about the diameter? Well, the diameter is twice as large as the radius. In other words, it would take 2 radii to equal the diameter. So I'm going to plug in 4.07 for the radius. Notice I put that approximate sign there because this is an approximate answer. That's going to make this an approximate answer as well. So our diameter is going to be approximately 8.14 centimeters. Notice I'm not putting the squared because this is not an area measurement. So it's just the length of the diameter. So it's approximately 8.14 centimeters. All right, so example 3, the directions look like they're the same. Find the diameter of circle T. So again, going back to my formula, area equals pi r squared. We are given the area of 325, so 325 equals pi r squared. We need to start by dividing by pi on each side. So I have 325 over pi equals r squared. Again, we want to get rid of the squared. So we're going to square root and use an approximate sign because that will not come out exact. So square root of 325 over pi. Again, 2 digits behind the decimal point, so we're going to say it's approximately 10.17. And all we have now is the radius, which isn't what we want for a final answer because we want the diameter. So remember, that's 2 times the radius, so 2 times 10.17, and we're going to get an approximate value of 20.34 feet for the diameter. All right, so a sector of a circle, it says, is the region bounded by 2 radii and their intercepted arc. It's kind of like if you have a pizza and you eat a slice of pizza, that slice is a sector. It's part of the circle. So just like that yellow piece right there, that is a sector. So in this next theorem, we're going to learn how we can find the area of a sector. Notice that we have a proportion. So proportions are nice. We have capital A over pi r squared equals the measure of arc AB over 360. So let me explain what each of these things mean. Let's think back to what a fraction means. You know, fractions are part over whole. Well, pi r squared, we just talked about that on the other side of this page, that it represents the area of the whole circle. And the A that's in the numerator is going to represent the area of the sector. So we have area of the sector over area of the circle. And that would make sense because the sector is part of the circle, whereas the area of the circle is the whole circle. So remember what a fraction means, part over whole. On the other side, we have 360 degrees. Well, what do you know about 360 degrees? It's all the way around a circle. So it is, let's see what the best word is getting. I'll just write whole circle. That's probably the easiest. Whole circle. Then in the numerator, we have measure of arc AB, and that represents part of the circle. Specifically, it is the measurement of that arc that goes with that sector. So again, you have part over whole. So you have your sector arcs measurement over the whole circle's measurement of 360. So if you can understand what a fraction is, part over whole, then this entire proportion makes sense. So we want the area of the sector, which is part, over the area of the circle, which is whole, equals the measure of the arc, which is part of the circle, over 360 degrees, which is the whole or all of the circle. So just keep that in mind. All right, so example number 4 says to find the area of the sector shown below. So we're going to use this formula. So A stands for area of the sector. Then we're going to do that over area of the whole circle using 2 pi r. We're going to plug in a 4 in place of the r. So I have 2 pi times 4 squared. Then we're going to set that equal to the measure of the arc. Now this takes us back to chapter 10, which is why chapter 10 was so important. The measure of an arc is equal to the measure of its central angle. our central angle is 45 degrees. That means that this arc is also 45 degrees. So that's part of the circle, and we're gonna put it over the whole circle, which is 360 degrees. Now with these types of problems, I always encourage students, if you can reduce a fraction before you start cross multiplying, go ahead. So let's take a look at the first fraction. We have a over. So let's go ahead and square the 4, which would turn into 16. And then I'm also going to multiply that 16 times the 2 that's in the front. So 16 times 2 is 32. Don't forget the pi. So 32 pi represents the area of the entire circle. On the other side, I have 45 over 360. And I believe both of those numbers are divisible by 45. 45 divided by 45 is 1. And 360 divided by 45 is 8. So that's what I mean about if you can reduce a fraction, go ahead. Now notice I didn't say cross cancel. You cannot cross cancel in a proportion. The only time you are allowed to cross cancel is if you are multiplying fractions. But because there's an equal sign in between here, you may not cross cancel. So all I can do is reduce either the left side or the right side, or maybe both. Now that I've reduced, I'm going to cross multiply. So 8 times a is 8a. 32 pi times 1 is 32 pi. And then I'm going to get a by itself by dividing each side by 8. And I'm going to get that the area of this sector is 4 pi. Now I do want to include units. Oh my goodness, y'all. I just did that whole problem and totally just realized I put a 2 right here. Oh, the later I do these videos, the more mistakes I make. Jeez Louise. Okay, Miss Wingard goofed. Let's do some erasing, shall we? I'm so sorry. I gotta stop doing these videos late at night. That's my problem. Okay, definitely not 2 pi r squared. That's silly. Our formula for area of a circle is pi r squared. Now, if we were in the classroom, I would have said, why didn't anybody tell me anything? But I'm sure somebody would have said something. Okay, pi r squared. So the r squared, 4 squared is 16. When we cross multiply, we're going to get 8 times a equals 16 pi. And that means our answer is going to be 2 pi. Woo! Now we're talking. And they don't give us units, do they? Nope. So I'm going to write units squared. And that would be the area of the sector. I apologize, y'all. I'm so sorry. I'm tired. Okay, so let's try this again, and hopefully Miss Wingard will not screw up quite like she did on the last one. All right, so we're finding area of the sector, so that's the capital A. We're going to do that over the area of the circle using pi r squared. We're plugging in a 6 for the r. Then we're going to set that equal to the area of, the measure of this sector, which in this case is 120. Remember that the measure of an arc is equal to its central angle. And then that's going to go over the whole circle, which is 360 degrees. All right, so we have A over 6 squared is 36, so that turns into 36 times pi equals, we have 120 over 360. I've got a 0 in the top and a 0 in the bottom, so if I divide out a 10 and get rid of those zeros, I have 12 over 36. Both of those numbers are divisible by 12. That's going to reduce to 1/3. So now I'm going to multiply across. 3 times A is 3A. 36 pi times 1 is 36 pi. And we're now going to divide each side by 3. And we get that the area of this sector is 12 pi. Again, they didn't give us units, but we're going to write units squared. All right, no screw ups on that one. Yay! All right, example 6, we're going to stick with the same formula, area of the sector over area of the circle, pi r squared. What are we using for r? We are using 7 for r equals. Now here's where you have to make sure you're paying attention. So we want to do the measure of the arc. We want the shaded arc, not the white arc. So in the picture, we're given the measurement of this central angle, which gives us the measure of the white arc being 170, which is not what we want. So how do we find the measure of the shaded arc? Well, if a circle is 360, we're going to subtract 170 away from 360, and that's going to leave us with an arc measurement of 190. So notice we did not use the 170 in our proportion because that is not the measure of the shaded arc. We had to find that first. And then we're going to put that over 360 because that would be the whole way around the circle. So we have A over 7 squared, turns that into 49 pi, equals, we have 190 over 360. Because they both end in a 0, they're divisible by 10. That turns that into 19 over 36, which cannot be reduced any farther. So I'm now going to cross multiply. So if I multiply across, I've got 19 times 49, which is 931. Don't forget the pi, equals 36 times A is 36A. And now we want to get A by itself. So I'm going to divide each side by 36. And they don't have anything in common. They're not going to reduce. So we get 931 pi over 36. Again, they didn't give us units, so I'm going to say it's units squared equals the area of the sector. All right, these are pretty easy, I feel like. As long as you know the formula, not too hard. All right, so let's try example 7. Again, we're doing area of the sector. So that's what capital A stands for. That's part of the circle. We want it to be over the whole circle, which is pi r squared. We're going to plug in an 11 for the r. Excuse me. We're going to set that equal to the measure of the arc of the shaded region. So in our picture, we have a box right here, which tells us that this angle in white is 90. That also tells us that this arc measurement for the white angle is 90, which is not what we want. We want the shaded arc measurement. So 360 minus the part that we don't want, minus 90, is 270. So we're going to use 270 for the measurement of the arc of the shaded part, and we're going to put that over the whole circle, which is 360. Okay, so 11 squared, that turns that into 121 pi. Again, both of these numbers end in 0, so they're both divisible by 10. I'm left with 27 over 36, both of which are divisible by 9, so that leaves us with 3/4. Now, one thing that's good about these is you can cross multiply, which is what I've been doing this whole time. But if you think back to solving equations, really I just want to get A by itself. Right now the A is joined to 121 pi using division. What is the opposite of division? Multiplication. So what if I just multiply both sides by 121 pi? We could do that if you want instead of cross multiplying. All right, so this is like 121 pi over 1. These can't cross cancel. Those can't cross cancel, so we're just going to multiply straight across. 3 times 121 is 363. Don't forget the pi. And then that's going to be over 4. And again, they didn't give us units, so I'm just going to write units squared. All right, so those problems I feel like are pretty easy. You just really have to know that formula. So if you can remember that formula, then these are a piece of cake. Let's take a look at the bottom where we have the last two examples, and it says find the area of the shaded region. Okay, how do we find the shaded region? Let's just talk ideas before we start throwing numbers in there. If we want to find the area of the shaded region for letter A, I need to find the area of the big circle. And then I need to find the area of the small circle. And I want to subtract the small circle away from the big circle. So in other words, I want the yellow part. So I need to find the whole circle and then subtract the white part away. Hopefully that makes sense. So here we go. All right, well, how do we find circle area? That's the formula pi r squared. So pi times r squared. So let's look at the big circle. What is the radius? Well, according to this, the radius is 20. All right, same formula for a small circle, pi times r squared. What's the radius of the small circle? Well, it's right here. It's a 4. Let's do some math. 20 squared is 400, so I'm just going to write the 400 in front of the pi. I like the way that looks better. So 400 pi minus, back here, 4 squared is 16, so that is 16 pi. Now notice those are like terms. They both have a pi. So 400 pi minus 16 pi is 384 pi. And now we just need units, and it's going to be meters squared because it's area. So the area of the shaded region is 384 pi meters squared. All right, let's see if we can apply that idea to B. So we want, again, the shaded region. So remember over here, we did the big shape and then we subtracted out the little shape because the little shape was the part that was not shaded, it was white. So maybe same idea here. We need the big shape. Well, what is the big shape? It's a square. So we're going to need to find the area of the square, and then we're going to subtract out the white area. Well, what is the white area? It's a circle, but specifically it's 4 circles. So we're going to do square minus the 4 circles. Hopefully that makes sense. All right, let's talk about a square. How do you find the area of a square? Well, you have a couple options. You could do length times width, you could do base times height, or you could do side squared. Because remember, in a square, the length and the width, or the base and the height, they're the same. So that is going to be a 12 times 12, or a 12 squared area. All right, now we're going to do minus 4 times the area of the circle. So again, this is where we're going to do pi times r squared. So pi r squared would give us 1 circle, and then we're going to multiply that by 4 because we have 4 of them. Now here comes the part where you got to use your brain a little bit, because we need to figure out what the radius is of those circles because we don't know it. Here's what we do know. We do know that this side of the square is 12. Well, what if I draw this line right here? Watch me draw it right here. That is the same as that, is it not? So this line that I just drew is 12, which means each circle has how much in it? Each circle has 6, and the 6 represents the what? That's the diameter. But we need the radius for our formula, which is pi r squared. So remember, a radius is half of the diameter, and half of 6 is a whopping 3. So we're going to plug a 3 in for the radius. Hopefully that made sense. All right, so let's do some math. 12 times 12 is 144. Back here, we have to do the exponent first. 3 squared is 9. Now I'm going to multiply that 9 times the 4. So 9 times 4 is 36. And then I still have the pi, so 36 times pi. Now these two things right here, those are not like terms. So I can't actually do subtraction there. So I could say that my area is 144 minus 36 pi inches squared, or I could use the calculator. Now I'm going to go ahead and put an approximate symbol because I know this is not going to come out to be the prettiest answer. So we're going to do 144 minus 36 pi. And then I'll do 2 digits after the decimal point. So I'm going to say that it is approximately 30.90. So that area, that shaded region, is approximately 30.90 inches squared. Now you don't need both of these answers. I personally don't care which answer you have. I would like you to be comfortable with going from one to the other in case when you have a quiz or a test, you have a multiple choice question and maybe this is one of the choices or maybe this is one of the choices. I don't know. I just want you to feel comfortable with being able to go back and forth. But again, you're using a calculator, so it's really not that hard. You're just working that index finger out and giving it some exercise. Okay, so that is it for 11.5. Tomorrow I will have yet another video for 11.6. Hopefully I won't make it quite so late at night so that I don't make quite as many mistakes as I did tonight. Thank you for putting up with that, and I will hopefully do much better in the next video.